Hello, good day viewers, and you're welcome to the third part of this video. All right. So in this question, we are asked to use the method of completing the square method to determine the roots of the equation, which is this equation that says 5x squared plus 12x plus 18 is equal to 0. All right. In other words, we are asked to solve this quadratic equation using completing the square method. So how do we do that? The first thing is to subtract the constant from both sides. In this case, the constant, of course, I want you to know that the coefficient of x squared here is 5, the coefficient of s is 12, and the constant here is 18. So the first method of tackling problem like this is subtracting both sides with the constant, all right, or taking this constant to the other side of the equation. And if that happens, I'm going to have that 5x squared plus 12x is equal to minus 18. Now, after doing this, now we are going to divide all through by the coefficient of s squared. Now, the coefficient of s squared is 5, so I'm going to divide all through this equation by 5. So if that happens, I will have that x squared plus 12x over 5 is equal to minus 18 over 5. Of course, if this is divided by 5, the 5 here will cancel, so that's why I no longer have 5 here. Okay, so after doing this now, the next thing to be done is to square the coefficient of x and add it, take the half, square the half, square the half of the coefficient of x and add it on both sides. First, you need to understand that from here, the coefficient of x is 12. Then from here now, the coefficient of x is 12 over 5. All right. So at this stage, you are going to take the coefficient of s, then take the half and square it. So from here, the coefficient of x is 12 over 5, and taking the half, will be multiplying it by 1 over 2, and that will give us 12 over 10. Now, squaring it will now be this. All right. So the coefficient of s is this. The half of the coefficient of s is 12 over 10. Then the square of it is 12 over 10 all square. So now it is this that we are going to add on both sides of the equation. That is the second rule. Therefore, we are going to say that x squared plus 12x over 5 plus this now, which is 12 over 10 all squared, is equal to this now, which is minus 18 over 5 now, plus this again, 12 over 10 all squared. Since we are asked to take the half or square the half of the coefficient of s and add on both sides, so this is it. We've added it on the left and we've equally added it on the right. Okay, please take note of that. Now, next thing to be done is to evaluate the left-hand side and also evaluate the right-hand side of the equation. Now, evaluating the left, according to binomial, I want you to know that the whole of the left-hand side of the equation is same thing as x plus 12 over 10 all squared is equal to, so this now is equal to the whole of this left hand side you see. So if you attempt, or if you expand this thing back, you should be able to have the whole of this back. So now this is now equal to what? The whole of this. So let me from here now, with my calculator here, evaluate the whole of this and write the answer here. So I will have minus 54 all over 25. So this now is actually the whole of this right hand side. So the next thing to be done now is to square both sides. Take the square root of both sides rather. So if I take the square root of both sides, which will give me something like this. Now this square root will cancel this square here. Therefore, x plus 12 over 10 will be equal to plus or minus square root of minus 54 all over 25. So notice that this square root is for 54, is for minus 54 and also 25. Very, very important. And of course, this plus or minus comes in because whenever square root is introduced in any mathematical expression or equation, plus or minus will always come in. Okay, so having said that, we can now say, now let us take this plus 12 over 10. Let's take it over to the other side of the equation such that x will be equal to plus or minus square root of minus 54 all over 5 minus 12 over 10. Now watch what I've done here. This square root is for minus 54 and also 25. Now, but at this part now, I've taken the square root of 25 to give me 5. That is why the square root is no longer for 5. All right, so it's more like I've evaluated the denominator to now give me this. So the square root is now only for this minus 54. And this now, which is positive initially, has moved over to the other side of the equation to now have negative sign. Okay, the next thing to be done now is to take the LCM of the denominator. All right, so this and this, the LCM of 5 and 10 is nothing but 10, such that 10 divided 5 gives me 2, and 2 multiplies the whole of this will still give me plus or minus 2 root minus 54. And 10 divided 10 gives me 1. 1 times minus 12 is still minus 12. So this is what I have at this point. So what I'm going to do next now is to finally evaluate such that I'm going to get the answer of this when it is plus. I'm going to get the answer. I'm going to evaluate the whole of this using only plus, and also evaluate the whole of this using only minus. All right. And of course, if I do that, please take the note of this part. Let me clean up this part. Okay, so I can now have that x, or let me just say x1 is equal to plus 2 square root of minus 54 minus 12 all over 10, and s2 is equal to minus 2 root minus 54 minus 12 all over 10. So this is x1, this is s2. Now, of course, I can use my calculator here to evaluate the numerator, evaluate x1 and also x2. So if I do the evaluation, what am I going to have? We have already solved it down here. If I do the evaluation, what am I going to have? I'm going to have that x1 is equal to minus 6 over 5 plus 3 root 6 over 5i, and x2 is equal to 6 over 5 minus 3 root 6 over 5i. So very important, what this I here means that this thing is a complex root. And of course, if you press on your calculator square root of minus 54, it will give you math error if it is a non-fancy calculator, all right? But if it is a fancy calculator like this natural display Casio that I have here, you find out that it will evaluate the whole of this. If you put in the whole of this now inside this calculator, it will give you this as the answer, all right, in form of a fraction. And of course, it can equally give you the answer in decimal. But what this answer means is that, these two things are complex numbers. All right, so of course I've made a video under complex number. You can go and check it out. So this is the real part, and this part that is having I is the imaginary part. So for the second value of x, this is the real part and this is the imaginary part because it has I. All right, so what it means is that in general, one can deduce that this quadratic equation has no real roots, but it has imaginary roots. All right, so no wonder the roots land into complex numbers. So that is it for this video. Very, very important to take down the notes. All right. Okay. So see you in the next part of this video. That should be part 4.